Okay, here's our topic, calorimetry. Here's our objective. We're going to do copper, calculate its specific heat. And here's the definition of a calorimetry. And here's what a calorimeter is. And the first thing I'd like to do is I'd like to draw what the calorimeter looks like. Now, a calorimeter basically looks like you've got a chamber. It's easiest to draw a cup. And I've drawn two cups within one. And that's because these cups are often styrofoam cups, and you're going to stick something in it. And this thing here at the bottom is going to be some sort of to stir it, a stir bar, or you may use a stir stick, got something that'll come in and you'll stir manually. It should have a lid over the top. All right. And this top thing is a temperature probe or a thermometer. So there's my chamber, and that's the styrofoam cup, and that's a magnetic stir bar. A magnetic stir bar. All right. That's generally what it looks like. So here's another picture of it. This is one, it's a little more fancy. It's made of metal. Here's my probe. This thing here is the stir bar. You take the lid off and the temperature out. This is like the inner chamber. And these two, this little gasket here fills this chamber with air, and air is a good insulator. So little heat gets out of there, the center chamber. And you can see here's the reaction chamber a little up more close. That's what it looks like when it's in the actual thing. Here it's out of it. All right, and this is where you put your temperature probe or your thermometer, and here's the lid. All right, now we're going to calculate the specific heat of a metal. So we're going to first have to figure out how much water we put in there, and it's about 81 grams there. All right, we're going to put this into the chamber. We're going to take the initial temperature reading, and then what we're going to do is we're going to get our piece of metal, this piece of copper, all right, and figure out how much of it we have. Then we're going to heat it up, all right. Typically, you want metals have a small or specific heat, so you need to get them pretty hot and don't use a ton of water. So you can see what it is. It's initial temperature reading there for the copper, all right. And then in this bath, I let it heat up, and there it is. I've done that, and then I take it out and I put it in my water, and then I would let it reach thermal equilibrium. And you can see there it is. It's about 25 and change. All right. And then, so now here's my data table. I needed to know, I measured these things, and therefore I got like this. And I wanted to know my specific heat of my metal. All right. How am I going to do that? Well, I'm going to do it out on paper. The first thing you got to remember is, and this is really important, is your energy heat loss is heat gained. All right. So the metal lost heat, the water gained heat. You can put this negative on either side. It really doesn't matter. All right. And I'm going to use the same formula, and that being mass, specific heat, time, and change in temperature. And I'm trying to solve for this variable, so I would divide both sides by these variables. All right. And that's going to end me with this. All right. Then I'm going to plug in my numbers. I get this. Now you notice here that those two negatives are going to eventually make it a positive number because they're going to cancel out. I'm going to multiply these three numbers and multiply those two numbers. I get this, and then I divide that by that. And I get this. My specific heat for copper is that, all right? And my unit is joules per gram per degree Celsius. And you might be thinking, well, how do we do in terms of specific percent error? Well, the accepted value is this, all right? And that's my experimental value. Here's PE equation, all right? I plug that in, and I get about 10% error, all right? What were my error sources? Well, there's always a little exchange to the surroundings, and if you look at, hold on a second. So why would my specific heat be a little low? Thinking this may have been a little bit below 80. So I had a little less water than I thought I did looking at that. And another thing, you notice that right there, there's a little bit of water there. So if I added less water than I put, that's going to make my specific heat be less than it should be, or what it's expected to be. But that's just food for thought. All right. So I hope this has been helpful, and have a good night. Bye.